Full screen. Full screen? ఇక్కడ So any guys gone through ICC commands? Any guy like anyone has gone through ICC commands and manual?
For manual, for what?
For manual, like everything.
You asked me like commands. What?
No, I'm saying like anyone has gone through user guide will be there. Manual, ICC manual.
Okay.
And ICC command difference. Anyone has gone through that? Then yesterday or like before? Yeah. Please go through that. So, and anyone has gone through pickle comments, all those things? Not much. I think it's better to learn tickle and we'll just show. So one thing. So you guys can come close if you are not seeing. I just want to show like what is the tool I have written, that's it. For your understanding, so that in future na, so whenever you are learning tickle, कुछ दूर में so I am working on Redog, so we'll all be doing Redog runs. So here we run the runs. So these all are the partitions except this file. These all are the blocks. So normally what we have, even as forget about the block names, don't ignore, but we have these many directories and these many blocks are there. So normally even if we run ICC will be like hardly one guy will run 2 or 3 blocks, that's it. So Redog we need to run these hundreds of blocks, and the reports will be in some particular format. We'll have one directory, reports directory, post CTS, then report. So that's how even in Redog also we'll have some files. So here we have to go to partition name. We have to go to partition name again, and we have to go to SDRV summary, and we have to go to past. Don't remember that directory, but these many directories are there. And if we go inside, we'll have all the runs, static or dynamic, what all the runs we have, we'll have. And in this there will be a folder, and here the reports are. Here are the reports. So and summary reports will be like, I'll show you. So these many directories we need to go every time, and here is one more summary. This is let me hide it, and this is a final summary file. So this we have generated based on our format. So what I have done is like, instead of going into these many directories, we have static, dynamic, thermal, and like EM, power EM, everything we have now. So we have to go to each and every directory, and we need to analyze all those things. So we have created a file, summary file. So here we will show like what is the static, dynamic, and all those things. So thermal, forget about that. It's a run. That's it. So it's only Intel related one. They have one tool, LTE tool, so local thermal quotient or something, it will be there. So based on that chip temperature at that particular point, it will calculate the EM and what are the IR for that particular cells and nets. So that's how in industry, like, no one uses that, only Intel.
Target diagram is there.
Hmm?
Target diagram.
You ignore these questions, so I just want to
Yeah.
explain you what the tool is. So target and redoc concepts also I'll explain once. So let me complete this, like, or else it will go this session, this tool, it will go 3 hours. So we have generated a summary file like this, and to see each and every summary file we need to go to all these directories every time, and we need to get this file. So instead of that, even manually, even if we want to open the tool, then we have to go to some other directories. We have to create a temp directory and we have to link the design, then there we need to open the database. So instead of that, what I have written is like, I have written a command. Okay, oh, sorry. So I have written a tool, smart and control. Okay, I don't have function. I'll go to my local agent directory that has run by my other teammates. So suppose this is the directory and this is a tool. So what I'll do is like, hey, why no internet? Smart and all. So this is a tool. It will just show like all the blocks we have and what is the reports. So if it is 0, then only it will green. If it is 0 to 50, it will be yellow, and if it is more than 50 violations, it will be red. So that's how this one. And if you want to open the particular report, so in dynamic we'll have in dynamic we'll have power nets, 3-4 power nets, we'll have 4 files. So we need to open 3-4 files. So if we double click on that, it will show all the files which has, like, based on the power net it will sort. So this is a power net, and for this power net, what are the dynamic violations? So if we double click on that, this report, we don't need to go inside. There are no violations here in this report. So first of all, we need to see summary. In summary, only one has issues, 18 issues are there. So that too in only one power domain we have. So in VDD Digbee's power domain, so we can directly open VDD Digbee's. So that's how we got this report. So we don't need to go to all the files like this. And even if we want to open the DB now, just we can double click on this. Okay, for now I will show. So redoc is opening redoc. It will open the redoc internally and it will show the GUI. And even then also we can operate all these things. So that's how we can operate on all those blocks, all those things. If the summary is not generated, it will show summary is not generated. But for all the things, summary is generated. That's how. So like, it's better if you learn coding now. So redoc is open. It will open and the DB will also load. It's okay, we'll forget that. We don't need this DB. So that's how. If you learn scripting and if you coding now, even yesterday I have seen that awk commands, piping, getting now. So if that commands you don't know now, then you have to do all the manual things, iteration things. So that's how it was simple now yesterday. In 1-2 minutes I did. So that's how it's better to learn scripting. So and this and we have one more so for the inputs we'll get redoc guys will get the inputs from PNR guys. So if you are run any block or something, you will dump what are the inputs required, like dev, spef, and all the prime time collaterals like timing windows, all those things from one area. So we need to check. You guys say like I have released, and there will be release area, and I need to go and check what is the latest tag in that release area, and if in the tag, like, we have to run for that tag, but before running now, so there is no check in until like whether the inputs are like quality is there, like it will have a tag, one directory, and in that directory we will have all the spef, def, all those things in their own directory, their own format. So we need to check whether that file is there or not there. Most of the PNR guys, they'll release only half data. Even for that also we need to run, and after running we'll check that if that run crashes, then we need to go to the logs and see because def is missing in that, like in the latest time def is missing, whatever the release we are taking, inputs taken from ITC, right? In that def is not there because of that run is crashed. So instead of running, normally I have shown there are 30 blocks, and normally 60 blocks will be there. So for 60 blocks we cannot go manually check like each and every tag, what is the latest tag, and is there any def or missing all those things. So what I have written is like I have written a, so this is just like for all the projects, it supports all the projects. So if we select some project now, it will go to this corresponding release area. For every project they will give one disk. This is the release area. So only from this disk PNR guys, like Redog guys, will get the inputs from PNR guys. So PNR guys need to update that disk. In that disk, in a format they need to update. And so for all the project, not only for one project, I have written for all the projects. So these are all the projects we have. So for all the projects, and what is like you want the latest current, these things you can ignore. This is work related. Okay, latest. So it will go into the latest tag. And if we give that path now, I'll show explain. These are all the blocks I have. So to check whether the inputs is present for all the bundle or not, it will go to, we have to select, my project is 806. So I need to go to that project. I need to give what all the partition list I have, blocks list I have, like at least block list what I need to check. There will be some other blocks also in that, but we need to check only for these blocks. So it will report what are the inputs for Redoc is like, we need spef, we need clock report. This is like all the clocks will be there. It will generate from prime time, timing window from prime time, RV text, it's from prime time, and we need nlib. He placed is some other thing you ignore. IPF is instant based power file. So we require all these files, and it will show whether for this block spef is present, clock report is present, timing window is present, like all these things. If anything is missing, it will report missing. So that's how. So it is just like now it's just a matter of within 1-2 minutes it's done. Or else we need to go to each and every tag, each and every block, each and every like spec is present, list is present. And if anything is empty na, some guys will there na, some intelligent guys they will touch the files. That means empty files will create. So it will also report empty if anything is empty. So that's all. So it's better you learn scripting, and this like all the technical commands can execute like all the tools. I think I have explained that. So it's better if you learn technical. That's all.
Is that Linux command? Linux commands,
Really?
yeah.
You all those things are Unix commands, but this is written in Tickle. This tool like I have written in Tickle. That's it. After it's done now, it will show it is still running for SOC. After it's done, it will show like please quit the window. Yeah, please look at the window. So we have all this. We can put XLS and we can send it to them. So that's how it's better if you learn. Mainly so that's it. Yes. Once ನೀವು ಕೊಡ್ತಾನೆ చెప్పండి Yesterday only 4 girls. One is missing. Yesterday also you 3 guys came.
No, I didn't come.
Okay. Oh, you are new joining, sir? What's your name?
Sucheta.
Sujayata. Sucheta. Kannada?
No, Marathi.
No new guys, na? So, how many guys have done the placement experiment? Creating the bond and can you please open if any guys have done, can you open the laptop and the design So like we can see what the reports we have. And one more thing I said, one is that, and other is I have given two experiments. One is placement, and yesterday I have said something. Cloning. Anyone has done cloning? And any more doubts like from yesterday class? And except that missing buffer. Okay. So whenever you insert any buffer, so in the terminal itself it will show is inserted this cell. It will give some full hierarchy cell name. So you can select that cell and you can do chain selection, get flat nets and that cell name. So you can highlight in the window. So you can know that where the buffer is added. And insert buffer by default it will add on the pin you have given. So in the layout there is a cell and there is a pin, Z pin. So it will go and add on that pin itself. It will not be legalized. We have to manually legalize that. So today, is there any topics I need to explain for you guys or? Okay, all you guys are comfortable with PT and then I just want to like you know like all the tools that's I'm going to PT. Or if you want any like anything in ICC or Encounter, I'll explain that. Star RC. No one in the industry will use Star RC. You don't need to worry about that. They'll give one file. You just need to source that. Like they'll give one file. In that file, we need to give our def. We need to give our netlist. That's it. You just do source. No need for netlist also. Only def we need to point and we need to source. Star RC you don't use. when we save one design in one version, so ICC and Encounter can load any design from saved from any version, but Redoc, Star RC, this PT, DC, these all tools. So if you save you are using one version, so this is the version, so K this version. So whenever you are using this version, you have saved some data or some session you have saved. In PT it is like in ICC Encoder it is in either def netlist we can save, or else like .enc and Milky Way ellipse we can save. In PT we need to save as sessions, so that full session which includes all the constraints we have read, all the files, def, all the netlist we have read, libraries, everything, it will be stored inside that session, and all the constraints what we have, so everything is done. So we have to store as sessions. So if we store one session in one format now, we in later when we try to load that session, we need to load in that particular version only. So here I have like in the industry this is common. So here it is saying like cannot restore the session saved with version. So whatever I am restoring this session, it is like saved with this version, and it cannot this version cannot restore that, so because we are using. So now I am using the same version, so now I can load this session because the current version is this, but I'll load some other session. Directory not found. Lab node, lab noise. Oh shit. Shut. This is also saved with this version. All the sessions are saved with that version only. What I'll do is like access. So from the here this is the version. So whenever if we source this file now, if we source this file and if we do ptps pt shell, then it will open this version only. So we need to open some other file. So this is also the same. ptpx. Yeah, this is with kit. Oh, this is also with the same. Then how come those guys have saved with different version? Oh. Who bought this, man? Who bought this like version? This Unix? You? From where you got all these things, man?
I bring on my person.
You?
I bring the.
How you got this bundle?
I give that money. They are installed.
Who has installed?
He's working.
Don't worry, I'll not do anything. I just want to know.
Working LNT.
In L&T, na? L&T guys, they'll sell this also.
Legally.
Oh, indirectly I am also an L&T company, L&T employee. Graphene, L&T bought Graphene now. I am Graphene employee now. So how much you paid for this? 20k. For 20k they have given this much, huh? సేవ్ చేసింది ఒక వర్జన్లో సేవ్ చేసిన 18 ఓకే 2013. So we have opened that particular version. So now we have that. We'll load from this repo. Restore underscore session is a command. So from here lab 3 voice. So now we have, oh shit, PWD I have done anywhere. PWD. I think we cannot use this PT. Anytime anyone have load the PT, I think that PT version we cannot use. Okay, we'll give up on the, we'll try last time. This we have done. This I'll try this. We have the same version. Okay, forget about PT. PT we may not, we can like, the PT is not supporting that whatever the version we have. So is there any topics do I need to explain to you, or I will continue with creating the voltage island? Is it fine? So if we have SDC and all PT, database is opening. Give me that.
You simply directly type prime time.
No need to source, without sourcing.
Please, after sourcing, directly type prime time.
Yeah, prime time it is open. Are you able to load the DB?
DB files. DB.
Restore session.
DB files is not there.
I have also opened the PT. Opening the PT is like this, it will show the terminal. We need to load the DB and we need to work on that. So custom EDI. Is there any EDI? Anyone have opened Encounter? EDI is there? Okay. .enc is not there. So we can use from the previous version itself. I hope if it works then it's fine. Yeah, it's loading the netlist. So it's working. So this is how you can load the DB. So there's a DB we have, and we'll do load floorplan is also done. So from the previous versions only you can use, like there is no .vnc we can use, so you see all the command files and you can draw from that. So okay, this might be like this is not a place design, so we can do the placement, don't worry. So yeah, so these are all the memories we have, and why these lines are shown? A placed. So even within a single command also we can get all these memories and we can set. I think you all guys know db commands. Yeah, we can get db get top dot plan dot blocks macro plan dot objects yeah, okay, we'll do it manually. We have 4. I have used Encounter long ago. Placed. Placed. So now what I'm going to explain is like how to create a again still it is coming here only. Control R. still it's going to just a minute. Set preferences. It's not going happening. Placed. Still why it is not moving well. Fixed. Okay, I'll do. So we can set the attributes also. So hyphen help, hyphen name, reset, set attribute hyphen net, hyphen shield, hyphen net, hyphen net, hyphen net, hyphen net. Hey, anyone knows how to set this to placed man?
DB set status command is there.
We have maybe status.
No, drop that.
Top dot status placed. What is the help? DB set hyphen help hyphen name. Object hyphen hyphen name. Top dot selected.
Drop that.
We can get the selected also from so if plan
Instance root status.
top cell area flipro objects type boundary box area box well row score his score is arrow. No one knows like how to set the attribute. Recently I have used encounter ICC. All are ICC only. It's okay, don't worry. Guideline plan groups top dot from symmetry geometry plan not effect. Next pin is marker name net object type of package physical instances status power text plan dot pins groups spacing groups object it is in place status. Only if I move then it's going to this again going to be
Total instance of placement. Place status is there.
db
Set. Total instance.
installer is
Status.
hello block. Okay, just a minute.
Status. Last.
You are saying is status
PP.
p status. Okay, no
Placed.
we'll see now. No, it's not. It is still fixed. So okay, later you guys can debug. So I'll for now I'll go forward. So what I'll explain you guys is like, so how to create a voltage island. The concept is like, what is voltage island. So this, why I'm explaining this is like, now like I'm seeing even when I'm including the juniors also. So the multi-domains concept is must. So everyone has to know the multi-voltage, multi-domain thing. So multi-voltage means the power is coming from single pump, and we have just named like the voltage. So if we have two nets, VDD net and VDD underscore 1 or VDD underscore or SRAM, so the voltage is same and the power pump which is coming from is same, just only some one power getter. From that power getter we are changing the net name. So that's how. I think you all know the power getter. So power getter is used to generate voltage. Actually, like from power pump, what are the pump name and what are the net connected to the power pump, so the same net name will go to all the cells. So but what we need to do is like, if we want some other voltage now, we have to insert a power getter in that net itself. In that power net we have to insert a power getter, and we have to, power getter will have two VDD pins. So one is the input and one is the output, and from that power getter the voltage might be same. We can generate, like if the power getter creates some down voltage or low voltage or high voltage, then different voltage. So multi voltage means the voltage is same, one block might be on off. So whenever there is an on off now, we have to use power getter. That means from that power getter, that power will be coming to this standard cell rows, and from that standard cell rows, standard cells will get the power. So we can, if we off the switch of the power getter, then all the standard cells like will also be off. So that's how. So multi voltage we use only for on off, and we have multi domain. Multi domain means, so we have different bumps, and from different bumps we'll get the different powers. So the power value is also different, voltage might be different, current values, so the power values are different, voltage may not be the same. Why we use this is like, so even in the mobile chip, so camera is having like need not to be always on, and camera like only when we switch on the camera it has to open, and it has to operate in some different, like camera is not a big graphics or all those things, so we can operate with the low voltage also, and some other blocks of the CPU, all those things, they can operate in different voltage itself. So that's power conserving, like low power things. So to conserve the power, they are using all those techniques. So just different voltages we use that. So if it for high performance and high frequency thing, we need to be very accurate. So there we can use some high voltage things, and for all this camera, all those things we can use some. So if we have two power domains, so they don't go in between. That means they don't there is no rule like one has to be on or one has to be off. Both can on anytime, both can off anytime. But if someone says, it is just like based on the experience I'm saying, if someone says, have you worked on multi-domain, and if you say like one domain is off, no need to be that much accurate like one domain. But when you say multi-voltage, you have to say that this is a on off block and this is always on, because we use multi-voltage only to make something on or off. Then we don't need power getter. Like, so suppose here we have a voltage island, like here we have one voltage and here we have like some different lines. If the voltage is same, so if it's a multi voltage, we have A here, we have B here, it's a multi voltage design. So in this design we need to have all the power getters and all those things, connections should be different, net names, all things should be different, and we have to define that in UPF. So if it is not a switch on, always like on off block, then why we need to use multi voltages? Because either of one is switch on off block. That is the reason why we use multi voltages. So that is the reason why we give area on power grid, all those things. That means whenever you in an interview, if a guy asks or if you say I have worked on multi voltage domain, means you should say one domain, like certain logic is on off and certain logic is like always on. And if that guy asks multi domain, and if you say like I have worked on multi domain, means it cannot be on off, it can be always on also, like our whole chip itself can be on off. Then why you use multi domain, like why you use different voltages just for saving the power. So one voltage might be high and some other block need not to be operated in that frequency, in that voltage. So we can, so that's how you can say. So
different voltages.
Multi domain, multi voltage,
Different voltages.
yeah, multi voltage also we can be there. So I'll explain the concepts. So like multi voltage means the multi domain concept is there na, same as multi voltage. So multi voltage means we have two domains, or else from single voltage we are generating, from the power getter we are generating different voltage. So multi voltage is almost similar like these power domains, multi domain, because they cannot interact. So the thing is like, so you may ask, there is block A, there is block B. In our whole chip we have block A and block B. Our whole chip operates in VDD, and block A will operate in, like a module is there, a block, it is in VDD A, and B operates in VDD B. So we have three power domains now. So A can be on, like VDD should be always on, because our core area, like our chip should be always on. So in the full chip our block can be on off. So we have VDD A and VDD B now. These domains can be always on or like on off also. So for that, whenever a signal is crossing from on off to always on, let me give a look. Yes, I think you guys know this, or should I explain? So this is our block. In a full chip, our block might be always on off, whatever it is. So if there is a power getter, the power getters are there in our design or in some logic, it is on off. Power getter is used just only to on off the things. So we have certain logic is there here. This is module A and this power is VDD A. And we have the core and certain logic is there here. This B module, VDD B. And this is VDD, our core, all the stands and all those things. And here some logic will sit and all those. So here what are the mesh, here it is having like all the M7 to like, or M7 to M1, it will be based on VDD A to get this power to the stand itself. And here it will be on VDD B. And what are the like core logic, it will be on VDD itself. So suppose this is a on off block and this is also a on off block. So only our core area is like always on. So suppose we may, there will be certainly there will be some communication between these two communications. So if any signal is going from this to this or this to this, definitely you will face these interviews like questions. So what you will do when like from always on domain to on off domain, there is a signal. So what you will do, what we have to do? So it's just it's not a multi voltage, it's just in multi voltage, that's it. So what we need to do is like, we need to use clamp cells, so isolators, either to block the signal, to give always on. So the thing is like, it is, so there might be a case, suppose we can draw a truth table, VDD A, VDD B. This is always on, so it will be always on, and this can be off and off, this can be off and on, this can be off and on, this can be always on. I think you have gone through. So that means VDD is always on, our core will be always on, always on. There might be some cases where this is off and this is off, and this is off and this is on, this is on and this is off, and both can be on, like all three domains can be on. So what you guys will do, and all three are same voltage, only the power nets are different just because to make it on and off. So what we have to do is like we have to add a clam cell. So what is a clam cell? Clam cell has 3 inputs. So clam cell is just, it will have a enable signal and a input signal. So it takes our so suppose there is an AND gate here. So there is an AND gate here or buffer. So from this buffer one signal is going to this domain, from always on domain to on domain. So here there might be a case this can be off. So here it is like for this block this is input net. Input net. So the thing is like what are the output here, it is there, it is floating. So as I said, output sometimes can be floating. So here it doesn't impact our functionality. It doesn't impact our functionality. There will be cases from this input, this buffer to this buffer. So from this side to this side. So it is like it is input to port. It is output pin from VDDA. From VDDA it is output. Signal is going from VDDA to VDD. That means on off domain to always on domain. Here, so this is always on. So this buffer will work always, it will be on. So there might be a case where this is on. So then what are the input we are getting from this now? It is X, like we don't know what the value, and this will propagate throughout the logic. Is that it is not what we intention. So what those guys will do is that they will add a clam cell here, make in a always on domain only, and that guy will ask where you will add the clam cell. Always you have to add clam cell on always on domain. Why we need to add clam cell on always on domain? Because just because this buffer is getting off, we are adding the clam cell to give, I'll explain the clam cell also, to give some certain input to this buffer. Again the clam cell if we place in that on off domain only, then with this buffer this clam cell can also be off. So that's how we need to put in always on domain. So what this clam cell will do is like it has one enable signal and it will have this input and it will the output will go into this. So whenever this input is coming now, so whenever enable is 0, what are the input present here, it will just propagate through this. And whenever enable is high, whenever we give enable signal, it will give either 0 or 1. So we have two types of clam cells, clam 0, clam 1, isolation cells. Clam cells and isolation cells both are same, don't go to like in network also. So clam 0, clam 1. Clam 0 means when the enable is high, it will give always 0. That means the net is connected to ground. That is what in CMOS design between, I think I have shown you in person. So if the clamp is not high, like it is not like if the enable signal is not high for clamp cell, it will give the whatever the input is present, it will just propagate that. So that's don't go into that logic. So that guy may also like what is there in the clamp cell. It is just some AND or logic. So what it will do is like you can create that logic also. Whenever this is 1, it has to give 0, and whenever, so we can also create. That is just simple logic. So that's how is a clamp cell. So this is one thing. So here is also same case. Whenever there is a signal going from this to this, we can. And that guy may ask, so why? So whenever a signal is going from this domain to this domain also, then is this case. Why you are like I'll add clamp on those situations also. We can say you add it. Don't worry, you add it. But it's waste of necessary, like waste of area. And however the signal, even the clamp output is also not going to anything. It will not generate any functionality. It's just waste. So that's how we can say we can ignore from always on domain to always on means A1. So always on domain to on off domain. We don't need any clamp cell. But whenever a signal going from on off domain to always on, clamp cell will be used. So suppose you said like multi-voltage now. So if this is operating in 1 voltage, then this is operating in 1 voltage. Don't care whether it is on or off. Always on or something like this can be on off, this can be on off, both can be off, both can be on, always on. For sure we need to place level shifters. There are two types of level shifters, level high, level low. So what the level high level shifter will do is like it will take the low input and it will give. Suppose this is operating in 1 volts. This is operating in 0.8 volts. This domain. So whenever signal is going from here to here, we need to put level high. So it will take 0.8 as input and it will give 1 output. whenever the signal is going from here to here, na, we need to add that. So and I think you guys know about retention resistance.
So where is close?
What?
Isolation.
Isolation.
From always on domain to on off domain. Where will be?
Isolation cells. I said na. Isolation cells and clam cells are same.
Oh,
Always
sorry, and isolation is level shift.
level shifter that you can place it whatever. Level shifter is there na. So it will not take this as input. It will not take this as input. So the from the top level power bump will be there na. Like always on power will be there. It will take from this. If suppose in this case it can also be always on, like it is our core na. It can also be the main power supply, main power net VDD mind you. So it will take input from always. It will get an input of 1, but based on that input signal it can give 0.8 or 1. So there is a level shifter which converts from 0.8 volts to 1 volt, and there is level low level shifter which takes 1 as input and gives 0.8 as output. In the for both level shifter the input is always on, like whatever the VDD we have, that 1 volt is there, 1 volt is the input. I think so
This information we will get from top level or we will have
level shifters.
level shifters.
Actually the thing is, like, anyone has seen the UPF? Okay, for now I think it's time for you to learn the way. So I think I'll explain the UPF thing. VLSI.
Password.
Yes. Oh shit. Save CPF temp underscore CPF. మనీ చెప్పు. హలో, మనీ చెప్పు. నేను ఇక్కడ వేరే ఆఫీస్కి వచ్చిన అమ్మ. వచ్చండు ఆయన తర్వాత వస్తాను. ఎన్ని గంటలకంటే అయిపోతుంది, ఇంకో 1-2 అవర్స్లో. 1-2 అవర్స్ అనుకో. ఇంకేమైనా సరే సరే. Okay, our design cannot handle this multi-domain. So I'll show you the UPF thing. You have Google now, Chrome. So normally what CPS will have is like it will like the power information is there now. So whatever the standard information logically we have in netlist, and whatever the physical information of those standard cells memories we have in def. In the same way, whatever the logical information regarding the power, it will have in UPF or CPS, whatever it can be. It cannot connect to net na.
Remove the blue.
ఏం చేయాలి?
Just Google.
వచ్చింది. And then we level modules, and they first they have to define, like whenever it is like some tickle proc I have seen na, the netlist is there na, the netlist is also a tickle format. SDC is also a tickle format. So we can see all those things, but it is in tickle format. So what it will do is like, first we need, even in we have written some proc na, this is also like a proc. We need to define the proc, then we have to work on that proc, like we need to call that proc and what are the work it is. So in the same way they'll declare top level module and what it has to be done in that, and then they will call the top level module, and then they'll create the all sub level modules. So creating a module like module and all those things, they'll create 9 netlist. We can use that or we cannot use that. Whenever we call that module, then only we like it is present in our design. It is present in our like what are the netlist, inside netlist we have. Before that it is just declared, that's it. We are not using that netlist. So in the same way UPF also will have one by one step. The first thing like for the power, what is the initial thing we need to get?
Power connections.
We need to have create the domain. First we need to create a domain. So RTL with UPF exam. Create domain. I think here UPF is not there. Oh, this guy is using the UPF. So it's okay. I'll tell the command, you can note down. So create power domain. So we need to create the power domain. So power is different thing. I said multi domain and multi voltage. So in the same way, domain is we have to, for every like what are the bump connections will be there na, that belongs to the domain, and it can get some different like V different R based on the resistance it will be there, but some power we need to declare some power value for that. So first thing we need to create is like create power domain, and then create power net, then create power voltage. Like we have to set the voltage for that power. So how many domains are there in our design? That many domains we need to create a power domain, and then create supply net, create ground net, and what is the voltage for that supply net and ground net. We can have n number of supply nets. Create supply net, create ground net. Ground net will also be 0, always it will be 0, so we can have only one VSS, and we can have, so that's how we declare the voltage, and from that supply net we have to declare like that supply net should be like some VDD or VDD underscore some SRAM, all those things. And then if we have any clock gators in the design, we need to set here only. Create like insert clock gator, some command will be there. This is the domain, and these are all the cells. So we will instantiate only once, and it will be like cloning, like clock gating cloning will be there. In the same way, this will also be like a cloning. And then we need to give connect some connect pin or something will be there, that command. So what that command will do is like we from the as a format we need to get our blocks is in what are the instance we have. We need to give all those instances slash VDD pin to this pin. So we either VDD pin or VSS pin. So our normal standard cell pin will be like VDD and VSS. So we need to connect this VDD pin to that supply. Then only what tool will do is like it will have a routing. So logically it will connect. That's how. Physically it will connect. Logically if we connect, then only it will connect as physically. So that's how. So that's how they'll create. So why so now I am creating voltage island. Why we require voltage island? Suppose our block is on off. It has to be on off to create a voltage island. Voltage island means it is just a island, like it is just a space where all these cells present in that like area is using some other voltage, some other supply net, or our block is on always on, so it is getting some other power, that's it. So our block is an on off block, on off block. So there might be a case our block will be like off, but we need some signals too. So there might be a, from here there are some pins and it is going to here. These pins has to be like working in some other power domains, like some other blocks. So these pins has to communicate, this has to go through all those logics, either buffers or like AND gates might have present in our design. So we need to place that buffers are like, we need to somehow see these buffers or what are the logic present in between these pins should be on. So that's how what we will do is like, because of power getters our whole block will be having power getters, and if the power getter enable is high, then it will like all our block will be off. So for that we will create some area, voltage area. Then what we will do is like, we will place that cells, we will create some stand cell follow pins, we will create the top level mesh, and we will connect that mesh to any one stripe going from through top. So that's how these cells will be always on. So it is they are no more getting the power from the power getters. So that's how. For that what I'll do is like, I'll open any power planning data. So anyone has opened Encounter previously in this? I need power plan data. Placement reports. Oh, we have route ENC. We have only one ENC. We have only one ENC. Edit ellana. Floor plan block implementation function. You have any .enc, power.enc, power.enc? Yeah, okay, we have add ring and add stripe is also there. It's okay. What I'll do is like, I'll open Encounter maybe. This is EDI 10. tool setup, source, EDI item, operation not permitted. Why? Encounter. Hey, I'm in FE, work FE, oh shit. So, so what I want is like, I want to add the stripes, that's it. So after creating the stripes, we need to connect to that. Check. 10.11. From 10.11 is this version, and 10.5 it is in like inverse. So what I'll do is like, I'll do the same from any old encounter command file. And just set variant, create analysis, create db, create library set load f place, load config. Create RC corners. Dot fp we have, dot v, we have dot v here, at least dot left, def we have, dot config. Netlist dot slash verilog left all dot left verilog. Okay, we have verilog here. Dot file. Hey, we'll have one file, load config, default dot config. Okay. Because it doesn't exist. Shut. Setup చేయాలి అదే DTF ఓకే నేను ఇక్కడనే క్రియేట్ చేద్దాం ఒకటి ఇందాకేదో ఫైల్ చూసిన క్రియేట్ పవర్ గ్రిడ్ డాట్ okay. Okay, we have power man. Okay, we have power planning. So okay, so now what I'll do is like, suppose we don't have any IO pins, edit pin editor, bottom left. Okay, all these pins are unassigned, so what I'll do is like, I'll assign some pins, don't worry. So here AHBSO underscore in, so this is one format and we have many pins. Let's see, we have out for that. Oh, we don't have any out. We don't have any out.
First one.
ఒకటే ఉంది ఈ ఫార్మాట్లో అవుట్. సో వాట్ ఐల్ డూ ఇస్ లైక్ I'll take the 78 pins and I'll assign in M4. Depth is like some 0.5, width is like 0.5, and spread in checkerboard we have an option, checkerboard M4 M5. Starting from, we need to give a point from where that pins should be start. So start from this point. From this point it will start adding in a clockwise direction. Spacing 0.5 is okay. Use grid, manufacturing grid, assign pins. Okay, it's okay. Okay. Hey, where are those pins? M4 M5 is on. This pinator is used to place the pins. It is not assigned. Unassigned. Till 30 at least I'll take. Fill in checker model 4 5. Do we got any report? FN status unplaced. Oh shit.
Side you are building as second below the name of the side we need to specify.
Yeah, we need to specify on. Okay, this is okay. 0.5. So this is how we need to place the pins. IO pins. 0.5. I'll okay, spacing I'll put 1. Let's see. Yeah, we have IO pins here. Oh my god, they have overlapped. Spacing I have given a little bit less now because this is M5 and this is M4. It's okay to place, but I'll somehow I don't want this position. I'll remove this editor. Okay, width I have put 0.1 and spacing is 0.1 now. They have overlapped. So I want the top one. Control A. All these in M4 and M5 in the top only. Width as 0.5, spacing as 1. Okay, checkerboard fashion starting from this to this. We don't need any end point, we need only starting point from here. We can give some rough location also for that. Editor, pin editor, Control A, M4 to M5. So you guys know clock and this clockwise and anti-clockwise. Spacing is 1. Yeah, so we have still it is overlapping. I have given 1 0.3. Then why they have I'll give little more spacing. Pin editor, top, Control A, width, spacing 2, clockwise, anti-clockwise. So is this okay? A start point and point M4 M5. Start point is this, end point is this. Clockwise spacing 2 is okay. 0.5, 0.3, M4 M5 top, everything is okay. Manufacturing it. Still now they have overlapped even more. It's okay, however it might be. I don't know why they are overlapping still. Spacing 2 I have given, but spacing here it is not 2, I think. From here to here it is how much? Okay, it'll see this spacing, I think. Like M4 to M4 it will see. Edit, pin editor. Okay, I'll do in only M4, then it will be fine. Just spread from the starting point. Spread from starting point. I'll do only in one layer. So spacing is 1. Width, depth, everything is okay. So we have placed these IO pins. It should not be that much long. It's okay for now. So we have these IO pins. Suppose these IO pins are having some communication. Instead of that, we can create also. Create pin. I'll try. Create underscore pin. Okay, this is the create signal pin. I'll try once, because we want, like, the thing is like voltage island is like I said now, there are some signals going from our block to some other block. That logic might not impact in our block, but they have to be always on our block, because our block is always on. So what I'll do is like I'll do some create pin. Pin is name, create a signal pin and switching. Okay, I'll create pin hyphen inst Rama. Block or area inst within. Name, list of instances, string, the signal pin. Get ports, export port. Okay, for now I'll use that only. So what I'll do is like, so these pins are input. Okay, so these are the input pins for us, so they are coming inside. What I'll do is like, for all these pins we now create a cell. So those cells are like what are the cells we need to create now. So normally whenever we are creating voltage islands, by default we'll create voltage islands only for the feed throughs. So feed throughs is like, feed through means that port itself doesn't have any logical connectivity. It will just have some input like feed through pins. What are the pins? What are the top level guy he give now? He'll give that pins, and in the bottom also he'll create some pins, or else now he'll ask us to create pins. we have to create the pins bottom, we have to create pins in the top, and then we need to connect that pin to some wire, that wire to cell, that cell to wire, and again that cell to wire, like pin, like a cell, and from that cell we'll go to the output feed through. Suppose we have one set of input feed through ports here, and these feed through ports will go to here. These are the outputs. So this doesn't have any logical connectivity, this doesn't have any logical connectivity. What we need to do is like, we need to, from this input in one feed through port, we should add a cell to that port, and from that cell it should go to this, because for every 300 microns we need to add one set of cell. So if the distance is more, then we need to have two sets of cells, and it has to go to that. So what I'll do is like, where are our cells, pins? One pins ekkadamma? Hey, where are our pins? Here me please. Okay, here. So here are our cells. So what I'll do is like, I'll take all these pins. Get report underscore selection. Report selection. So we'll have that pin name. So instead of this report selection, so we can directly get this and like we can edit. So instead of that, what I'll do is like, I'll do Control L. Sorry. We have an option. Okay, what I'll do is like, edit pin editor. So we want only the selected one. So this is an option. What is option? Select highlighted in display. So whatever we have highlighted in there, it will select that. So it has selected this. So we'll get all these names. We want all these names. I'll create one file. The file name is gvim pin.rpt. Shit. Okay, I'll just do report select pins.rpt. Actually that arrow is there now. Redirect will not work in these tools because they are written in Tickle. So Tickle doesn't support that redirecting. So we have here, we have file pins.rpt file. Abba devare. Oh, we haven't selected a. Yeah, now it's not empty. So we have this. So we need only the pin name. So as I said, we can grab name from pins. So we want all this. So from this, what I want only the column 3. Then what I need to do? Awk. So we have all these pins. gvim pins.rpt. Edit, select all, delete. I'll not save this file because I have to use it here now. I have all these files. I'll paste it here. So this is up. What we can do is like percentage slash space. So like I have removed the new line and I have created with space. So these are all the cells. Set pins to this. I'll set this pin to this. For now I'll do it for this only pin. So I need to add a net. So first thing is like it is simple. So suppose this, what is this query? So what is this? It is AHP like M0. This is 0 pin. So what we need to do is like we need to create a net with net name 0, and then we need to create a cell, and the output of the cell should go to somewhere, some other port. So for now what I'll do is like I'll make it to like I'll just create the inputs. I will create the output also, don't worry. Okay, for now I need to create a input to this. So like input means I have to connect this to a cell. So what I'll do is like okay, and I need to place that cell here, somewhere here, don't worry. So I need to place those cells here, all the cells. So what I'll do is like I'll create the cells. create create underscore cell. What is that command? Create cell, or here it will be like create inst or something over there. Cell. So set see, is there any create cells? We don't have. Inst. Is there any create inst? Add inst we will have. Add inst. Yeah, add inst. So what this command will do is like it will just add inst hyphen physical or cell name. We can give the cell name and the master cell name. So we need some master cell name. So what I'll do is like so this is a cell. Add cell hyphen cell is this hyphen inst. So what will go like it'll add a antenna cell like this. We can give the instance name also. So before that we need to get the lib cells. So we don't know the buffer format. So we need to get the lib cell now. So what are the cell names? The command format you have seen now. Add inst. We have to give the master cell name. So we have to get the master cell name. What is the? We need to add a buffer. That's it. So what the buffer master? So how to add? In an ICC I have said get lib cells */* that buff if we give, we'll get all the lib cells we present. So I don't know here in encounter. Lib. Anyone know? Okay, get lib cells */ buf library. Filter. Man. So man get lib cell. So we need to get we need to first give the library pattern usage. Okay, get lib cells */ hey, we have na, it is also same LCA.
There is some cell view, or we can see the cells there.
Yeah, we can see there also, but the command, every time you go through this command only, it will be helpful. Okay, maybe we don't have buf. Hey, cannot find the match. Cannot find the results for the match. And we don't have any buffer. We don't have buffer itself. Filter star అయ్యో దేవుడే. T buff, okay, they have T buff. Okay, capital, shit, I am just Jaffa guy. With the capital names they have, we are searching the small name. So, okay, I'll create buff 8, I'll create buff 6, okay? Okay, buff 6, buff 3, buff 8 I'll create. Okay, what is that? Create, add inst, hyphen cell. నేను ఎంటర్ ప్రెస్ చేయలే కదా. add inst hyphen cell this hyphen inst. What is the instance name? So for now we need to have some like notation. I'll create with the same name. What are the name it has there, I'll create it with the name, same name. So I'll give it this name itself. This inst name is already taken. Okay, I'll create it as underscore cell underscore this. Okay, so I have created this cell and this is in unplaced status. And what now I'll do is like I have to create the net. So create net. Anyone open Encounter and search for these commands. Set net, select net, report net, get net, delete net, add net. Hey, add inst ఉన్నప్పుడు add net ఏ ఉంటుంది కదా. add net man command. So that's how we need to add the nets. So I'll just do it and add net. And what is the net cell name we have given? Net underscore. I'll just add net underscore this. So we have net and we have cell. So it is, they both are like logically not connected to anything. So we need to connect net. For connect net anything, anyone can open the encoder man, anyone. CO and connect edit. I think it is edit net. Edit net. Edit net. Is there any command? Edit net. Edit change net it will be. So here what we can do is like to any net, so we can simply give edit change net hyphen net. Oh, this command just to change the net name, that's it. Change net associated with the selected. Yeah. Star connect. So what all we have? Where do we have connect net? Edit, create, delete, add net to dump display CO, edit, get nets. We have any connect net option? Get nets, reports nets, report, set net, select net, select in net list, set, unify. Anyone search in Google? Edit connect, I think. Edit only we have. Edit file, edit change net, edit cut wire, edit split, edit stretch, match, delete, edit route, so how to add అబ్బా ఏమొస్తుంది?
Command option is there.
What? Into
So in window, then there is an option in command, full command.
edit
In that corner, full screen, full screen.
full screen.
No, full screen.
Make it full screen.
Drag to the right.
Okay, here it is. Help. Command line we have command line, but in that also that what are the commands we have, that only we'll get now. What I'll edit while view partition select all and we are I'll check in Google on my edit man. Edit change status. I haven't changed on edit trial. Select trim via edit set edit. Okay. So encounter net connect CONI connect net to instance connection net to instance global net connect might be this a higher power net cadence encounter user guide. Don't worry fine name. So I think it's better if you find net name encounter. PGNet pop insta from 11 Mair. So I think it's better if you learn all these commands. Now get inst connection to the net, instance db get RAM object. I want to know if there any command. So most of the commands set collection, set query object, report net we have. Cadence support లోనా చూడండి ఏంది ఇదంతా select net limit ఏంటిది అకౌంట్
క్యాడెన్స్
అకౌంట్ అవసరం లేదు ప్రస్తుతానికి. అయ్యో సెలెక్ట్ చెప్పు ఇదా ఇదా
ఇది
C__ N చెప్పు KRUT పాస్వర్డ్ silent. ఇది ఫుల్ స్క్రీన్ వెళ్ళడం ఎట్లమ్మా ఫైల్ ఫుల్ స్క్రీనా ఫుల్ స్క్రీన్ ఓ షిట్ తీసడం ఎట్లా నేను ఫుల్ స్క్రీన్ connect and connect to instance. Change net guys don't know how to. I've used long ago this encounter.
Structure we didn't do it.
This one, hello, I'll say in my draft. Don't worry. Actually, long ago in Qualcomm only have written a prompt to create automated to create a voltages automatically, and now I don't know all. Attached term. Attached term. ATTACH attach term. I think it's better you all guys go through this command reference. Okay, attach term whatever the port we have, so this port to this port to net underscore man detaching a terminal that drives an output terminal of a module level if you instead of attached to attached to like a new port instance specifies the instance contain the terminal which specifies the network which terminal of the does not have a new port name and module as an port specifies the hierarchy port used to connect specifies the attached term. The following term attaches the terminal in one of instance into net attached terminal to net using hierarchical port. The my port must have in the module in that case new port net 3 if you doesn't exist. Okay, I just want to connect attached term this term to this. Net name is required for command attached term module base new port. SSH to connect net port new water port. Cannot add any term the following command attaches terminal via of instance entry ఎందుకు నెట్ గ్రూప్ ఏంగా నెక్స్ట్ న్యూ హోల్డ్ వదిలేదు చూద్దాం attached is change and mounting port attach అన్నా నాకు ఇప్పుడు ఎన్కౌంటర్లో ఒక పోర్ట్ ఉంది, ఐఓ పోర్ట్, దానికి ఒక నెట్ని కనెక్ట్ చేయాలి. ఎట్లా? ఎట్లా అంటే లాజికల్గా అటాచ్ టైమ్ అని కొడితే వస్తలేదుగా. అటాచ్ టైమ్ పోర్ట్ నేమ్ ఇచ్చిన అవట్లే ఆర్గ్యుమెంట్ నెట్ నేమ్ ఈజ్ రిక్వైర్డ్ ఫర్ కమాండ్ అని వస్తుంది. ఇచ్చిన కదా అదే నెట్ నేమే. ఇన్స్ నేము పిన్ నేము నెట్ నేమ్ ఇవ్వాలి, కానీ అక్కడ ఇన్స్టాన్సెస్ కాదు కదా, అది పోర్ట్ కదా. ఓకే, ఇప్పుడు దీని నుంచి చేసుకోమంట. అప్పుడు రిప్రెంట్ డిలీట్ చేసి నెట్ కూడా పోతుంది మళ్ళా. నెట్ కనెక్ట్ అయ్యి ఉంటుంది, ఇది పోద్దంట. ఇంత పెద్ద ప్రొసీజర్ చేయాలన్నా. ఇప్పుడు ఎంత ఏం పడుతుంది? సరే. Okay, let me explain this later. So for now, instead of this port, we'll go through like from the cell I'll connect. Okay, that net is there and we have the cell. So from the cell we'll connect. So that I'll ఏమైంది ఓకే ఎన్కౌంటర్స్లో ఉందా. So we have a net name, a report underscore net. The net name is this net underscore net underscore. So we have మనం యాడ్ చేసిన నెట్ ఏంటిది? యాడ్ ఇన్స్ట్ తర్వాత యాడ్ నెట్ చేసినాం కదా. యాడ్ ఇన్స్ట్ add inst hyphen cell ఇది ఇచ్చినాం, ఇది ఇన్స్టాన్స్ యాడ్ చేసినాం. ఓకే, యాడ్ ఇన్స్ట్ సెల్, దీని తర్వాత యాడ్ నెట్ చేసినాం. యాడ్ నెట్ ఓకే, యాడెడ్ నెట్. సో రిపోర్ట్ నెట్ అండర్స్కోర్ నెట్. రిపోర్ట్ అవ్వాలి కదా, రిపోర్ట్ నెట్ నేమ్ వచ్చింది కదా, రాలేదు ఎందుకు? ఓకే, సెలెక్ట్ net. It has been selected. Okay, what we'll do is like attach term. So this is a cell we have, this is a new cell I have created. So from this cell, actually it has to be like this. So this is our design, this is a port, and we have created one cell. So what we need to do is like there is a net, I need to connect this net to this input pin A. So this port I'll connect, but this input pin A I'll connect. Okay, attach term of A to net, this is the net. So attach term syntax is like attach term, the instance name and the pin which is need to be connected, and the net name. So we have connected the net name. So what I'll do is like I'll create one more set of and then we can connect like we can create one more net, the second node of net, and we can connect to the Z net, and that net has to connect to the port or like some what is called port or instance, like whatever it is, next set of buffer. So what I'll do is like, so from here out, like I'll write a script. So here I'll create one set of 30 buffers, one set of 30 buffers, and then I'll create one set of 30 buffers here, and I'll connect these two. We have to connect. So how? I'll show. So first let me select inst. So what is the inst we have? This is the instances. So if I go here and if I do control T will not work here. If we go here down, okay, I'll do shift R. So whatever the small dot it is there now, that is our cell. What I'll do is like I'll place it here. Hey, where is that small dot? So here we have. I'll move this to here. So this is one set of buffer. Okay. Oh, first we need to change the status. What I'll do is like I'll do control R attribute. What is the command to place? Move selected object, move selected object hyphen common x and y. Place star set place mode, place install, place cell using, place connected, ECO place, check place, define place, and do one thing. So set up command, tag set place mode. You guys know the command like to move a cell. Encounter ever star set place place inst. This is the command. We need to give x and y values. So this is the place inst and this is the instances. We need to give x and y hyphen place. So we have this command place inst and we have the cell name. This is our cell name and we need to place it 100. Sorry, I'll put it. What is the location here? I'll place it somewhere here. Here I'll place 282 645. 282 645 if unplaced. So
Place. Only place.
where is that cell? Select inst, that instance name, zoom selected. Hey, it is showing here. Oh shit. Anna Chapana. సరే అది మాడ్యూల్ పోర్ట్ అంటే మన పోర్ట్ కాదు కదా, హైరార్కీ పోర్ట్, అది మాడ్యూల్ లోపల పోర్ట్ అది. ఉంది అవునా అట్లా వర్క్ కదంట అది మాడ్యూల్ పోర్ట్ అన్నా నేను ట్రై చేసినది అటాచ్ టర్మ్ కూడా అట్లా ఐఫోన్ పోర్ట్ పెడితే అదే అదే అనుకుంటా సరే నేను ఒకసారి ట్రై చేస్తా పిన్ నెట్ అట్లనే ఇచ్చిన నేను మళ్ళీ ఎగ్జిక్యూట్ చెప్తా అయిందని ఏడిటి ఎస్హెచ్ అటాచ్ టర్మ్ సెల్ నేమ్ ఇచ్చిన జెడ్ పిన్ ఇచ్చిన అదే ఇన్స్టెన్స్ నేమ్ ఇచ్చిన జెడ్ పిన్ నెట్ నేమ్ ఇచ్చిన నెట్ అండర్ స్కోర్ ఆ తర్వాత పోర్ట్ అని ఇచ్చేసి ఐఫోన్ పోర్ట్ అని పోర్ట్ నేమ్ ఇచ్చిన ద టర్మ్ జెడ్ ఈజ్ నాట్ ఏ లీగల్ జెడ్ నాట్ లీగల్ అని వస్తుంది నేను ఒక్క నిమిషం దానికి జెడ్ పోర్ట్ లేదా వై ఉందనా నేను ఇందాక నుంచి జెడ్ పోర్ట్ ట్రై చేసిన వై ఉంది వర్క్ అయిందన్నా అయింది అది వైకి ఏకి కనెక్ట్ అయింది అది వైఏకి వైకి కనెక్ట్ అయింది తప్పు కనెక్ట్ అయింది అట్లనే కనెక్ట్ అయింది అటాచ్ టర్మ్ ఇన్స్టా చూద్దాం అటాచ్ మాడ్యూల్ పోర్ట్ చేసిన సర్లే అని వదిలేసలే సరే నేను తర్వాత చూస్తా సరే చెప్తా sorry guys, we all guys have worked long ago on Encounter, so it's okay. You somehow you find a command to attach that port to the net, but for now I have attached that net to that pin. So what we need to do is like so this is a cell. So if we select this pin and report select, so that is a pin and it is connected to this net, and we'll create a Z pin as a out, like so we'll create one more net to connect to Y pin. So what is that command to create? Add net. So this is the net I have created now. For this 0 itself I'll create underscore y underscore. So that means net underscore is connected to a pin, net underscore y is connected to y pin. So add net and att attach term y, this y to one more net. So if you select this both, if you select and if you do report select, so a pin is connected to this net of this cell and y pin is connected to this net of this cell. So what I need to do, I need to add inst again, add inst. What I'll do is like I'll create two underscore, I'll create like the next level. That is the first level, this is the next level, and okay, that is in play state. Move what is that command we have place inst. Okay, hey, we have used some command to place inst na. Pls place, then why it is called place instances. Place inst cell name and place. Okay, this is the cell name, and I'll give some random location like, so only this location we can see the place cells. So I'll give it here. Here I'll put 342 647 342 647 hyphen placed. So if you go and see here, so that cell is present. So now I have to connect this Y pin to this A pin. So I have to add net. I have to add a net Y have added. So to this Y only I have to connect. So ADT A attach ATT ACH attach term ATT ACH attach term. So what we have to do, this is a net name is okay, this cell name it should be 2 and 2 A pin I have to connect. So if you go and check here, there is a fly line, but from this A pin to this out. So here small 0 is there na, this is out, it shows out, and all the X is there na, that means these all are the input, that means that is the input pin. So from here to here we have a fly line connection. So what I will do is like, I have created this manually, and this A pin is there na, this A pin you find some command to connect port to pin. This is must you connect, though you find the command, you take it as a workaround. So what I will do is like, I have created this manually. Suppose we have 1k of cells or 2k of cells. So what we need to do, we cannot do all these commands one by one now. So for this we need to do automation like scripting. So I think you all know tickle basics at least, tickle syntax. So I'll somehow create a script to do this. So for I'll create, so voltage island dot tickle I'll create, hash bang slash bin tcl slash bin. Hey, yesterday TCLSH we got na, slash etc bin apps. Yesterday I have written one file where I have written that, oh TCSH. Okay, it's okay, that is just a bang script. So you know, so what we have is like, we have two steps. We have to create a net, we have to create a net, and we have to create a cell, we have to create a net, we have to create a cell, attach this net to this A pin, attach this net to this Y pin, attach this, whatever the Y pin has connected, we have to attach to this. So and the naming convention should be, we have based on the port name. So first we need to take all the port names. So what I'll do is like, set ports. What all the ports? These are all the ports, and last one I will not take. Okay, so if you see this, we have these many pins, we have selected all the pins we have. I have removed that 0 because we have already attached a term to that. So if you see in this tickle, I'll show, if you for each, so we need each port at a time. So we cannot process all the ports at a time, we need each port at a time. So if we want to see each port, we can use for each loop, for each some variable we need. So single pin dollar some variable we can give dollar pins pins. So this command what it will do is like, so we'll execute this tclsh. We have tclsh now, tclsh, and that what is that b. So if we execute now that command, what we got is like all the ports at a time. That means for each loop what it is doing is like this for each syntax, I think you know this for each loop. From this list it will take first one into this port, and then it will put, and then it will go for the next one. So that's how we want for all the ports, but one by one. So we got the ports. Then what we need to do, we need to create a first level. For the first level we need to create net. So add net, and what is the net name? What is the net name we have to create? Here we have so we have to create a net name, net underscore that name for the first round. So what we need to do, add net underscore dollar spin. We have to add this net, add net only na, add net, and so that's how this net is created. And then what we need to do, we need to create an instances cell p, add instna, add inst is the command na, ఎవరు చెప్పండి కదా ఏదో ఒకటి. ఓకే, యాడ్ ఇన్స్ట్. అండ్ వాట్ ఈస్ ద ఫార్మాట్ ఫర్ యాడ్ ఇన్స్ట్? దిస్ ఇస్ ద ఫార్మాట్, యాడ్ ఇన్స్ట్, this is the format, that is the cell name, and this is how we need to create. So what this command will do is like, it will add this net underscore dollar is there na. Whenever in a tickle, whenever it is executing one command, the first thing after reading the first line, tickle what it will do is like, it will replace all the dollars. So before execution itself, it will all the dollar, that variable name is there, it will replace it. So now what that command will do is like, add net space net underscore whatever the pin we have given, that AHBM0 first pin is there na, so it will add it. In the next iteration of that for each, next command will come. So that's how it will create all those nets, and then it will create all those cells. So while executing this command also it will create. And then what we need to do, we need to attach term, attach attach. I'll see the syntax. So we need to place inst, we need to place that inst in certain location. So for now what we has done is like, we are placing this cell in this. Before that, so cell underscore dollar s underscore pin. So what I'll do is like, I'll place my first cell at this location. If I repeat this loop now, every time the cell will be placed here. So what we need to do, we need to get some expression like it should place next. So what we will see is like, what is the width of this cell? What is width of this cell? What is the width of this cell? 2.2. So we need to add 2.2 to that. Oh, 242 this now. So first cell it will place here, and from this we need some expression. What I'll do is like, I will move this pen to cell to here. Okay, first set of cells they will place here. I'll 2.2 is the width. So what we'll do is like, we'll set a variable, set x 2.2. What the x means, so why I am creating that x means, here what I'll do is like, I'll for this x axpr plus $x. So y is constant. Y. So what it will do, instead of 342 and 647, first time it is 2.2, let it be. What it will, okay, even this also I'll put here, set x 342, set y 647.52. so instead of here I'll do $x, and here I'll put $y. So what it'll do is like in the first expression it will add the cell at this location. So the x is like 362.2 and the y is like 647.52. so in the next expression what it will become, it will become 364. That means x have moved, so x have moved a little bit, but the y is constant, so one after another it will place. You got the point, I think. So one of that like y will be constant. For now only 30 is there now. So for that what you can do is like you can put a for loop. That means suppose here I have some 30 na. So what I can do is like I can put some 15 here. So in this for each loop, in that for each loop I need to put what is called for loop, one for loop. So for I equal to 0 and I less than or equal to 15. So what it will do is like in the, till the 15 it will do. Till that we need to set the y as constant. After that, completing that for loop, it has to come out now. When it come out, we'll do like we'll set y like with plus point with the row height we'll add y equal to y plus row height. So then it will come down. Then again one more for loop. What it will do is like, then we can do for each for that also. For loop for that also it will be good. I think you got now what it is thinking. So here we are executing for each and every block now. So if you till this, if we want to place in one row and remaining one if you want to place on the next row, what we have to do is like we have to put a for each loop. In this for each loop what we can do is like one for loop. So that for loop what it is like till 15 it has to run. Like suppose these are the cells till 15. So we are making y constant and only x is adding. So till 15 y should be constant, x we can loop that. After that it has become 15 now, or else here also even here also I can put what I can put is like these number of cells I can put in 1 and these number of pins I can put as pins 2, and I can put 2 for each loops. Instead of for loop I can put 2 for each loops. What I'll do is like first I'll set y as this now. I'll show what I'm saying is if I put set pins 2 I'll do set pins 2. Where is the command end man? End. So this I'll do. So now this for loop will happen only for this, and after this for each loop now what I'll do is like I'll put set y as I'll increase or decrease 657. So it will go up. What I'll do is like I'll put only one row. One row height if one row height is 1 then what I'll do 658.52. so first set of cells it will place in one row, and the next set of set it will place in one more row. Just because I'll put the same command here, I'll do the same here, it has pins 2. That's it. Okay, this only I'll do like this only. I'll do it this only. So for that I'll get this also 1.71 cell height. So 64 this place 1.7 what it will become? I don't know that much max. I'll just do expr $y plus 1.71. I'm adding that y. So I will now I have created 2 sets. So and now what I have to do, I have created the instance, I have added the net I have added the cell, and then what I have done, I have placed that cell. So now I just have to connect. So this is where the problem is. So the first thing to first we need to connect which term. So attach term, I'll get the syntax there. Attach term. So this is the syntax. Attach term. Home comment delete. So what is the syntax of attach term? Attach term, we need to get the cell name. What is the cell name? Dollar cell underscore dollar s underscore pin. And then what is a pin? A to what net? Net underscore dollar s underscore pin. So it will attach that. And next what we have to attach? att is attach term. Sorry. We need to attach term. What is the other cell? Oh, we have created only one cell till now. So we need to create one more set of cell. What we will do, instead of this add only this, I'll create the second one, to underscore, and to connect to this I need one more net. And what is that name? It will be to underscore. So this so then I need to place that instance also, to underscore. And if you see, the x and y should be different. I said I will place one set of cells here and one set of cells there. So we have to give different x and y. What I'll do is I'll just add 100 here, or 50. If we add 50, it will be 9. If we add 50 here, it will be 9. You got the point, I think? Oh, sorry. I'll x2 y2 here also x2, that x is common, y2. You got the point why I have done that? So the first cell will be placed at 342 and 647, and the next set of cell will be placed at 349 and 649. So in the different location. So first cell we have attached that first cell. So then for the second cell what we need to do? For the first instances we have connected to the A pin, and that Z pin also to be connected. What is that Z pin is like? P. I mean. Okay. So this Y pin is there. This Y pin should be connected to which net? Which net it has to connect? What I have done is so this is net underscore port name. This is net to underscore port name. This is cell underscore port name. This is cell to underscore port name. So what we have done is in the first element we have placed cell to underscore. This is cell underscore 2. So we have placed this cell. We have placed this cell. We have created this net. We have created this net. These two cells created and placed. What we need to do is for the first attach command, what it will do? Cell underscore port name. So cell underscore port name is this, and to this A port will connect net underscore pin. That means this first pin, this first net. So it is connected logically. Then next step what we need to do? We have to take this cell underscore port names Y pin and connect to net underscore 2. So yeah. So we have taken this A pin, cell underscore port Y pin, and then to which net we have to connect that Y pin? Net underscore 2. So we have this. So in the first command, A is connected to net underscore port, and Y is connected to net underscore port. Y is connected to net underscore 2. So net and net underscore 2 we have connected. And next step is like this net underscore 2 has to be connected to this port. So attached term, this net underscore cell 2 has to connect it to cell 2 of A pin, like A pin of cell 2. You guys following up, or like it's not interesting? If it's not interesting, tell me. Or like if it is not understanding, also tell me. It's fine, na? So I'm just logically checking. Why I have I'm explaining this tickle means. So tickle is most important thing. If you learn tickle na, then only you will understand the tool. These things we have. So if I do a proc and I'll name it as a proc underscore like voltage underscore proc, like create underscore voltage island, then it will become a command. So that is a command what we are using now. So all the tickle commands are proc. Add inst is a proc. So that's how. So tickle we need to understand. If we understand tickle, we can understand the commands of that tools. So that's how. And tickle procs are mandatory. You need to write some procs to create voltage islands, to get the cells, to get all the instances. There are a lot of things we need to do. So that's how. And is there any other step? One net we have created. This net we have created. We have created the cell. We have created the cell. We have moved the cell. What we are missing there? So we'll check. So when we execute this command, so we'll do the same here also. Down also I'll do the same. Okay, let's forget this. I'll put only one. Don't need not to be confused. Okay, we have taken all these ports, which has to be. Suppose these ports are feed through ports, and we have to add sets of buffers. So we have taken X, we have taken Y. Like we want to add two set of buffers to that port. So we have taken X and Y for the single portion, and X and Y for the second set of cells. And then for each loop, when we got the first net, we are creating a net underscore that port net. We are creating a net for first set of buffers and net for second set of buffers, and we are creating a first set of buffers, we are creating a next set of buffers, and then we are placing first set of buffers, then we are placing second set of buffer, and where we are placing this first set of buffers in some X and Y, you got, and the second set of buffers at X2, some other X and some other Y. So because and it will go like only the X is changing. So here the cell like one by one it will place in the single row, and there also in the second set of buffer also only in one row it will place one by one 30 cells. And then what we are doing, we have attached this term to A, we have attached this term to B, Y, and we have attached to A. So now we'll run. Let's run. Will it work or not? And we have closed the loop. Everything is done now. We'll source that in ICC. Encounter. Source VI. So it's done. If you see the log, so for last set of, so this is the last one. If you see, that is the last one. So we'll go for only this one. So what all things we have done? Instance is this. Okay. Here it is started. We have added a net because it is taking this one. So this is the last port, and we are creating a net. The first set of net. We are creating next set of net. And we have added the instances, first set of instances. We have added next set of instances, and they both are unplaced. Then we have placed those two. So first one is placed at this location, next one is placed at this location. You got? And then we have connected. So we'll see these connections are okay. Then we'll see in the encounter. So what happened? Where are all those things? So 93 are here. Why they have placed in single location?
Not given the space.
What?
One cell to one cell.
This is second set of cell. Why this second set of cell have been placed here? Oh shit.
Sorry,
X and Y.
we have to update.
No, the tool will automatically update. Okay, only one y I have given here. Okay, y is only one, it will be. X we are updating now. Here whenever we are doing place now, we are updating this x with 2.2. So we need to know whether this expression is working or not. What we'll do is like,
We'll change the name.
we'll set, we'll do all these things in encounter. Hey, sorry. So, and this is how you need to debug also. And they were yes. So this is our script, and we need to debug why the issue has been faced. So this we will do, and then what we'll do is like, we'll execute this command itself, expr this command. So whether it's working or not. So it's working. It's working. The problem here is, okay, have you guys like got what is the problem? The thing is like, we have not set x in this loop, and we have not set these capital X, like what is the set distance also in this loop. So what it has done is like, so every time whenever it is in the loop now, the x is constant, and this is also constant, and it is being just adjusted. So what we need to do, we need to put a command here, set small x expr $x plus $capital X. So what it will do is like, then no need to put here all these expressions. I'll explain you why I am doing this. So we have to update in the loop. So whenever for the first time it will come 342 plus 2.2, it will go to x and it will update the x. Then in the next time, this is constant, x is already 344 is there, then it will add 2.2 this. So this is how it has to be done, and we have to do the same for the x2 also. You guys got the point? So I'll do it for x2 also. Place to x2 also I'll do the same. We have to update in the loop, that values we have to update in the loop, and we have to place that here. And one more problem is, the second set of cells have been placed here only. It has to place somewhere 340 na, then why they have placed here? That is one more question. Why? Because what is the x2 value? x2 is 392 and y2 is 697. So where is that 392? Here is the 392, 647. Somewhere here it has, oh okay. Oh, that remaining 90 they have placed it here. Okay. And one more thing, this is second set of cell. Oh, here it is 90, there it is 90. How come it has added 90 cells? Okay, maybe pins also they are coming. We'll switch off that pins, don't worry. Cell. Okay, how to switch off that stand cells now? Okay, how to switch off these pins? I need not to select. Okay, and what I'll do is like, select inst with cell underscore star. So get underscore selection, report selection size of collection, get underscore selection. Sorry, what is that command? To get select. Report report select will be big, it will be too much big now. to get only the like number of cells. db get selected dot name. So these are the cells selected. What? No need size of collection also. Yeah, you know tickle, then it's good. L length also we can do. I'll do L length only. No. length. Length is a tickle command. By default we can use it here. So that's how. Spelling the. What is that spelling, man?
You have to put the bracket.
length. Length of this. So we have to give a list. So 62. Total 62. And what is the number of pins we have given? So here we have given these many pins. So what I'll do is like I'll set this and I'll put length $pins. So we have 30 buffers and there are 62 cells. If it is 30, then it should be only 60. It has to double. Then why 2 buffers it has been extra added? Because those 2 cells which I have created manually. So it's okay. This many number. So what I'll do is like delete inst. I'll delete these instances. And whenever you are removing anything in encounter, deleting an encounter analysis, you make sure, because few things if in encounter in ICC we'll have X down in that left side column, we'll have X in the bottom. So if we click on the X now, what it will do is like in that placed instances, it will go to unplaced, that's it. But it is not removed. So whenever if you do placement again, that cell it will come again. So whenever we are deleting something, make sure whether we are deleting logically or physically. Many things will, like all these tools will be there. Most of the commands will do only physically. If we do delete, it will just delete and make into an unplaced state, or like logically that cell will be there. So we need to delete that physically and logically. So make sure, that is the reason why every command has its own limitations. So you go through all the commands. Okay. So let's see the man page. Delete inst command is there. By that command itself, we know that it will delete the instances. But we need to go through the command whether it will delete physically or logically. We need to delete physically and logically. So we'll see. So delete an instance from a design system whether cloud. So logical or equal, whether the instance is logical or equal. You can give any cell and it will delete physical and logical both, and list the instance accordingly. So logical it will delete and physical it will delete. So we can use this command. So what we'll do is like, instead of these what I'll do is like delete inst cell underscore star. It is processed. Then now what I'll do is like, so no cells found. So they have been, so we have to do this because if there is any physical cell now, we can directly go to this encounter and we can see here there are no cells, it's done. But don't do like that, because it may delete physically but logically it may present. So we need to go and select that cell. If that selected cell is, we got something now, then it means logically it is there, physically it is not there. So you do this. And we have to delete one more thing, we have to delete. What is that? So first I'll get select net control E net underscore star. So size of L length $pins dbget.name. So we got 62. Actually how many nets we have created? 60 by the proc, and 2 I have created manually. So what I'll do is like delete net, and we have to read whether it's delete like only shape and bias it will delete, that means physically, and logically it may present. Remove net will remove only physically. Delete net will do logical and physical. So so there are wire segment use deleting it logically. Okay, to delete wire segment associated, use the delete net command. Okay, logically deletes nets from a design. If a net is routed, wire segment associated with the nets are also deleted. So that means logically it is deleted, and wire segments were also deleted. So logically and physically both it is deleted. And note, to delete wire segment associated with a net without deleting it logically, use delete net command. So and this is a command, and to delete without deleting it logically now you can use these both statements contradict now. Might be okay, we'll somehow we have an option I think. So what I'll do is like I'll do delete net, and what are the nets we have created, net underscore star. I have done, it is done, 62 nets are processed, and I'll do select net, nothing. So if we have got nothing in this selection now, that means logically it is deleted. Command line is logical, and whatever the GI is physical. So you got the point. So that's it. Now I'll execute this like proc again. I think you guys are noting down these commands and the procedure now. You just keep memorizing. I think this is the much practical thing anyone can explain now. So please remember that. So practically I am updating this x in the loop itself. x2 also I am updating in the loop itself. That means the for each loop. And I'm placing that cells. Hey, this I have forgot. This 697 is there now. That is not there in the design. It is going above the design. So what I'll do is like I'll create something like 680. Okay, 680 is the max. So what I'll do is like I'll add I'll replace with 30. No, replace with 60. Replace with 70 and replace with 70. Okay. Now why I'm doing is like that 697 is there now. It is above the design. So that's why they have placed in the corner. Mane వస్తున్నా కొంతసేపు వస్తున్నా ఇంకా బయలుదేరలే ఇక్కడి నుంచి ఏమందుకు ఏమైనా పని ఉందా సరే. So now let me execute this command. Source escape if you do now. Escape I think you all know. Yeah, in the command line. So this is a command line now. Previously I have executed source with the starting name. So if you do SOU and then escape, whatever the like it will take the history, and from the history whatever the latest match one. So with that SOU it will grep in the history what is the latest one, it will make that print. So now I'll execute this script. So it has added, we can see the last port is this, and it has added a net 1 net 2, that means two sets of net it has added, and the cell and cell 2 sets of cells it has added. Whenever it is adding now they will be unplaced, and whenever adding this also it will be unplaced. Then we have placed this in this particular location. If you see here the x is still the same, so across the loop. So we'll see in here, so where they have placed. Even still we had one set of cells here, only 3 now. So we have one set of cells here, we have one set of cells here. So that's how it is created all the nonsense. Just a minute. This is cell 2, this is cell 129. This is cell, this is first set of cell. Only one cell is placed here, so that means this problem is still exist. So this is second set of cell. I'll move this cell to here. This is second set of cell, 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 this is second set of cells. So all second set of cells have been placed in one location. So 670 it is becoming outside. So what we have to do, still the x is not being updated. So we'll check the proc why it is being not updated. So the x we have given a constant value 2.2, and it is being set. Oh shit, no, we have given the small x only. Then it has to update in the loop.
second set you are not updating that.
Oh, it should be
You are
x2.
placing $X is fine.
X2 it should be x2. This is what you are saying, no? But at least that first set it has to be
Here you can remove the
what?
the expression. Yes, on that line.
This expression, yeah, I meant this expression. So we need to know why it is. So what I'll do is like, instead of adding all these things, you can do Control V and down arrow. Like what are the lines we need to add? Down arrow, you come down and then you do Shift Insert, Shift I, and then you write whatever the things you want. I want to just put hash, then put escape, so it will automatically add to all the lines. So I'll uncomment only these two lines. Why X is not updating? My question is that. So what I'll do is like, I'll puts puts $X, puts puts $X2. So let's see why it is not being updated. Even then again I have to remove DLE, delete escape P, shit, DLE, delete escape P in delete inst cell underscore star. Delete and net underscore star. This time only 6060 because manual things I have removed previously only. Now I'll do source. So what it is printing? It has come to this. Hey, now it's being updated now. Every time X and Y is different. No? Then what happened previously? X and Y, it is being updated now. This X is different, this X is different, this X is different, this X is different.
It's good to add it, 2.2 to add it.
What?
2.2 add it.
Yeah, every time it is adding 2.2. Then I can do Control V, select only these lines, delete. So now what it will do, 342 it will come, 647 it will come, and then it will update to 344. Y is constant. Y also we need to change. No need to change Y now. Do we need to change Y, man? I'll make it, replace it to replace with 5. Can we hope good data today? Good data now? It's okay? Slide source? No. Still okay. Now the X and Y has been updated. So we'll go to the report, we'll see. So this is where. So this is how to create a voltage element. And this is simple part. Now to these instances, suppose I'll select all these cells. I'll do, you want like this now, I'll place it like this manually for now. So these instances should correct different voltage. It should not be the current voltage. If you see here, the follow pin is same. What we need to do, the follow pin should not be same. What we have to do is like, we have to manually select all these. You know how to cut a cell rows. We have to select all these nets. चाउट सर ने कौन से पढ़ा था कॉल जाना था हाँ नो हाँ नहीं सर okay. So now we need to manually go to this where the voltage element is present, and we need to cut all these wires. So we had cut again. We need to select these 4 wires because we had cut, but it still physically it may like in the design it may show like till here, but in the GDS they will be connected now. So then what we can do is like either we can stretch also. So now these you can do X, all the markers will go. So now these and these has been separated. So if you see this, if you click on this, where it is connected, it is net VDD. It is connected to net VDD. We need to create a power VDD underscore 1. So create net. Okay, for now we'll do edit. Add net. Logically we'll add VDD 1. So we have added, and what we'll do is like we'll select all these lines. Actually we should not add through this command. Through this add net command we should not create. One thing with Encounter and ICC is if you want to create any power net or ground net, you need to close the design. Whenever you are loading the design, in that power net files, like during the config it will show. In that file itself we have to give the name. Now we cannot implicitly make that, so that's why I'm making like this. So you don't create power nets or VDD nets with add net. They will be created by the tool automatically when we have to give during the loading the design itself, creating the design itself. I'll do edit, change net to VDD 1. What this command edit change net will do is like it will get all these what are the selected items, and it will change that net to VDD. So if you see here, it is VDD 1. Previously it was VDD, now it is VDD 1. So the power, it's done over. I'll cut these also, don't worry. I'll cut, oh it's already cut down, and I'll make this till here. Ayyo, sorry, what happened now? Even the net after this also it will make it as VDD 1. We need only net follow pin from here to here. What I'll do is like I'll select this one, this and this. So what I'll do is like, first I need to cut. Shift X I'll do. I have cut all these things. Shift X, and then I'll select these nets. Select. So I'll select these. Select. You need to do S. S means stretch. If you don't like know the commands, you can ask, like if you want to know what I'm pressing here, you can ask. A means normal mode. X, it will clear the markers, X markers. So this net is in VDD 1. I need to change that to VDD. Again I'll do edit net VDD. So again these nets have been changed to the old net name. So it's better after cut these things now, then only you change. So now the nets in this region itself only having VDD 1. So the follow pins have been changed. So what about these standard cell power pins? Those has to be changed. We can edit, change net. What we'll do is like we have to somehow get that power pins. Actually we don't have manual command, so in the create power supply itself, UPF file, I'll search UPF. Okay,
Sir, this VSS also we are making VDD 1.
oh shit, VS also I had made now. Okay, I'll change. cadence. Home page should be support that cadence document. We have already logged in, I think. Hope so. We have, and product is Encounter digital implementation. $130 now. Oh my god. No guys are hungry. Everyone had breakfast? Everyone had? You had? Thumbs up. Actually this power nets na, the problem with power nets is like the VDD pin will be there na, whatever the cell we have, that VDD pin, it will be declared as a power in the library, that pin. So we can connect only the power nets to that pin because it has attribute power na. So whatever the nets we have created with add net na, that will have a default attribute signal, and we cannot change the attribute. Once the design is loaded, whatever you edit will changes na, the power nets will be remaining same. During the import only we have to change the power nets. We have to add this there is a power net this. Even if in the design it is not present also, it will not ask. There is no logical connectivity, there are no pins, it will not ask anything. Yes, we can put a number of power nets and then we can load the design. So then we can create some physical shape with that net name. So if I try to attach term of VDD to this now, it will give error. So that's what I'm searching for. So connect VDD pin to net command. Meantime I'll change VSS. So alternatively we need to change to VSS. So what I'll do is like I'll put this as, okay, just a minute, this is VSS now. I'll change this to VSS. Okay, capital or small? Capital. What is the command? VSS. So this is VSS. Anyone know how to get these pins of this? And pins. Pins. Object. And report. CLS select. Get underscore pins of object. So we have A and B. We need power also. Hyphen leave will even then also hierarchical filter HSC. Yeah, encounter na, it will not support to like to edit the power nets ongoing. So after design is loaded, we cannot edit the power nets. That's why it is not showing the pin.
In
So
ICC we can edit.
in ICC we can get the pin names, we can edit, but even that also, just we can somehow we can create a name, but it will not take logically. It will not take. While loading the design itself, we need to have that net name declared. This is power.
In the netlist.
Yeah, not in the netlist. Well, loading na, will in the config file we need to create, I think. So in the import design only, here we have to create power nets. What I'll do is like Hey, I have loaded this config manually, na? And placement? I think I have created loaded this config manually. Yeah, manually. I'll do. So how to? So I have done these changes now. Now I want these changes in the new netlist also. Hey, however I have now. So what I'll do is like I'll close this. Okay, we'll work in next workspace. If you guys are hurry now, I cannot do anything. I'll just complete this in half an hour. We don't have any new workspace. Okay, what I'll do is like I'll close this file. I'll open one more encounter here. So you guys remember how I opened the encounter? Hello. Change that to tool source edi 10 DTMF I just cut and encounter. These all commands is I did change it. These are all commands and what are the procedure I am showing. You related to like whatever things you know. If you want to do anything in the design na, so that's a like most of the things I have showing practically manually na. So you can relate it to all the remaining things and you can know, oh, this is how we can create, this is how we can edit the clock, this is how we can create a clock, this is how we can create a clock buffer. If we like we have insert buffer and we have add buffer and route. If those two are not working, or if those two, if you think that takes time or that that is not comfortable for you, like in that situation that will not work, you can do this also. You can create a cell, add those nets, add those pins, that's it, it's done. So that's how what I have done, man. Import design config I have loaded now. Load default config, open, and hey, where is the power net? Advanced timing LM power. So we'll declare power and VDD 1. It will not ask whether this net is present or not. It will not. It doesn't care about all those things. I'll do okay. Hey, let it run. Hey, it is exiting. Why? Hey, DTMF is closed, man. Previously also DTMF is closed. I'll show. Change directory tools, source, EDI 13, PWD. This is not DTMF now. This is some other design. What is it? Data Leon.video.
Leon
Give some water. So ls. How I loaded this Leon, man? This one. No one has noted down how I opened the encode itself, huh? Please note down like what all I am doing, because it's like waste of time when I am saying something and you have no. Record down. Video record also add audio. Audio also record, then it's fine. So you guys don't you don't know how I have loaded these files. So globals. So you just give some name, random name, what it is, like BDD1, and this is the only way you can declare the power nets and the ground nets. After loading the design, you cannot do anything. So what I'll do is like I have loaded all these things. I have loaded the left, def, everything is done. So what I'll do is like I'll do okay. So we have the design, and one thing is like how to change the data from one design to another design. So we have created all those cells there, nets we have created there, but it should come in this also, because there I have cells I have created now. I can dump a, this is some other design, man. What is this design? DTMF chip. Okay, it's okay. Okay, I'll source that here. Even here also it will work. I'll source this script is in now. So I'll source it there. So you can do the same in this design now. When you are loading, you add this power net, or else see somewhere in the config or something, you save this .enc. In the .enc, you go to enter into that change cd to .enc. In that config will be there. In that config, power nets will be there. I'll show instead of that. Save design rama.enc. Present working directory is this. What I'll do is like I'll go to this directory. I'm in that directory only. In this .dat, if you see, you have where is that globals? Okay, space dot preferences dot global. What you do is like, so this is the attribute initial power. Oh, it is created. How come, man? This is DTMF. This is from this design I have created. I have created this net now.
No,
How come it is automatically added as power here? I'll do one thing. VDD2 also I'll create. I'll close this. What I'll do is like I'll FREFT design. So how to open a database in Encounter? You guys don't know Encounter at all. Like when the starting of the class only you could have told now. How many don't know Encounter like before? You guys should tell even before now. After explaining all these things now, I could have whatever it might be, some people is there, but I could have explained like little things. I thought Encounter and I'm just going on.
That's why you are not able to follow you writing the comments in the others.
Definitely it will be. You cannot follow now. You should tell. So how to open a design, man? Source in Encounter. Yeah, that's how .enc is created. .enc is a format how Encounter will source. The thing is like in ICC we have mlib now, .mlib. So in the same way, now ICC2 has NDMs. So NDM it will NDM. So what it will have is it will save Encounter.enc will save all library information, left information. It will not save that library or text file. It will just have one file. That global file is there now. It will take where is the netlist, where is all those things. It will do import the design. It will load the def, then it will load the left of the physical design. So that's how .enc will work. So where is our design? Here is our design. How come? Hey, what happened to this design, man? I think I have read the long design. Let me close this. This is only now what I have saved for sure. DTMF only. Even the power came, we have everything we have. Hey, that is because here I am. Maybe it has saved from here, I think. But where is that sales, man?
Turn off the database.
Metal? Okay, metal layers is okay. Metal, nothing it is there. Select net. Select inst. Cell star. Hey, they were not found. Let me do exit. When I have saved one ENC, it has to load that ENC only, no? Why it is? I'll do it manually. File, restore design, import design. Source, Rama. This only, na? For sure. Okay, 100%. How come all my savings has... Okay, maybe before that, do I need to save design? Oh, when I save the encounter, it is saved already. How come I... Okay, what I'll do is like, I load fplan, load fplan from rama.dat to fp. Oh, dtmf.fp dot gz. Oh shit. Load def, read def, read load. What's the command to load the def menu? Star def. So load def file rama.enc.dat. Here we have .def. We have fp node chipnode opens place. I'll do one thing. If I design, I'll take import netlist from Rama. We need to take na. Where is that Rama folder? This one. This is the netlist. Close. And we need to reference libraries. Left file I load. Left. Where is the left? Rama.dat. Left is not there. Shit. A config. We can load config also. Fine. Restore design. Encounter. Restore design. Open. It's gone. Okay, what I'll do is like, even these power nets, all those things have gone. Let it be. Last time, what design I have loaded? So last time, what is the design I have loaded, man? How come, man, you guys are just in there? Encounter.log. Last time I have done this. You please note down at least this time. I have done this last time. Okay. Okay, so for now, what I have explained to you, I have explained to create a voltage island. I have to cut, explain you to, yeah, nets, and how to all those things. So again, you load some design, you do power planning on that, you do the same thing. For the power planning also, I have done something, I think. Okay. So you do the same things, same steps. Like the M1, I have disconnected that M1. You in the same way you select the M2 or mesh whatever it has. You highlight the M2, cut the M2 around this position, like this portion, and what you do, you edit net -2, and the remaining vias will be then M1 to M2 via, M2 to M3 via. Whatever you do is like edit via -2 this VDD1. So you got. So that's how it will be done. And then find the command. You have to find two commands. One command is to connect from IO port to cell pin, and next command is to find. So you note on this. Next command is how to change the VDD pin net name. So whatever the cell is there, whatever the instance we have, encode is showing A and Y. It will also have VDD and VSS. How to change that net names? Already it is connected to VDD. Now we need to change it to VS, like VDD1. So this is the two things. You make sure you do that as soon as possible and learn. So that's how voltage island is created. Then next step is how to add the fillers and how to add the end caps. Definitely I'll show that also in the next session. Maybe like you can learn now. You can like it is simple. We'll have set fill command like so add end cap is there now. So through this command get end cap mode, we need to set, we can set whatever we want. Set end cap mode hyphen. So we just need to know the cells, what are the cells, boundary underscore tab or incremental. So we need to we'll have one more command, bottom edge prefix, bottom right edge, right top, edge, corner, right edge, boundary tab, and set end cap mode. List of cell names. Okay, by default I have an incremental right edge, list of cell names. Okay, the thing is like you have to do, you just execute this command. You just do set end cap. You just do set end cap hyphen left edge, give what are the cells it should add on the left edge. You can give any cell, but for now from the library what I have said, get lib cells */* is in that you search END or DAP, decap or END, capital END, small END, decap, or at least you can add filler. You find some cell filler. So first we need to set this command, set end cap hyphen right edge, give some cells, left edge give some same set of cells you can give, hyphen top you need to give the same cell, hyphen bottom you need to give the same cell, because it will say that the right side what we need to add, left side, right side we can set like what are the cells we need to add in this, and at the edges also, like even there is edge now, what are the cells we need to add. For now you can give for all those edges, for all those sides you can give the same set of cells, and then you do enter. So it will just set, and then you execute add end cap. So what this command will do is like you just give hyphen area, and the area is like, suppose design is not on it. Suppose I have whatever the end caps voltage island area is there now, you just give little bit more than that. Wherever I have cut that M1 you little bit more area given that. By default end caps will be added only at the row edge. So wherever the M1 is ended, there only it will add, don't worry. Or else if it is not adding now, then you do cut row. At that point you do cut row will be there, you can do cut row. You can what the thing you can do is like you can place a okay source rama.enc source vi. Hey, that move command is not working on place inst. Why place command is not added? Place inst command has to be executed now. Even I have not commented also. Okay, this design is a little bit small. So if you see, it has added all those 180 cells are there now. It has added here only because whatever the area I have given is too much. What I'll do is like 30, 56, 67, 64. Remember the values. Thirty, 56, 57. We'll give some random number. 70. For now, I'll remove underscore net, delete net underscore star, delete inst cell underscore star. So you have deleted everything and then you execute source vi. So it has added now. So what you do is like you just take off of these cells, place it here manually for now. So for end caps you just give this location and this location. After adding the M1, I can add the M1 also, don't worry, I'll do it for you. So if you guys are new now, I'll LESS add stripe. Okay, grep add strip star add st. So this is the command add stripe. This command what it will do is like it will add the stripes. So okay, that this is for some other block and this DTMF is very small now, so the set to set distance is too much small. This is like there we have seen one macro now, this block itself is like half of that macro, so that's why. So you can create the follow pin, and after creating the follow pin to the end cap, you give this location and this location. It will add only where the M1 is there and not there, and you have to create a placement blockage before that adding that end caps. You need to create placement blockage. How to set all these cells, madam? Anyone know? Create placement blockage like this, and then how to delete these. Shift R. How to delete the placement blockage, madam? Anyone know? Okay, somehow you learn, and then what you do is like you just cut rectilinear. Just do this. It has to match this. Stretch bar. Okay. It is from here to here. We need to make it as placed. I have somehow made it as. Don't worry. Stretch can do cut also. Not cut. Why stretch is not working? Stretch is not working. Okay, I'll cut. I'll do cut. Okay, you can go to this cut and you stretch. This is only for the wire. Cut rectangle. Somehow only around the cells is there na. So around the cells we don't have anything. So you move little bit less this side. At least one row should be there. Down one row is there. Bottom one row is there. Huh? Okay, I'll leave this row. So now, oh shit, undo. So now, for now I'll execute this command. Just get underscore leave underscore cells star slash star. What is that? END. Sorry man, if anyone is hungry, sorry. END or decap. D. Hey, don't have any libraries.
Library cells names are different.
No. Previously, with this command only I have got all the library cells. Huh? Get lib cells star slash star. So okay, for now you can set help and what is that and star. So with this command name you set all the filler like name, what are the options I have given. So with the options I have said right, top, bottom and all those things, you give the cell names and then you execute add end cap and give this area. So whatever area we have given from here to here you give. So it will add two set of end caps. One end cap is around this here around this placement blockage, and one set of end caps at this end. So we need to add two sets in the voltage element. So inside it will add, outside it will add. So that's how we have added. So end caps we have added. It's done. So you change the M2 M3 edit net to that. So it's done. That's how you create the voltage element. I think you guys got. So next week, so you all guys prepare one voltage element, two sets. So this is the same for the next one also. You create this, edit the power nets, you create the end caps and you show it to me. Okay. You guys are clear, and is there anything else? Today class is like, is it good or not? So like you also, I am also, if today I am also learning the encounter like you, like I have forgot all those things. So how I have debug, if I don't know the command, how I have debug, to understand the command, how I have debugged, and to understand a thing. So every time it will be the same way. So in the industry you don't take someone's credit. It's like if someone does a good work and you say, go to a manager and say like I have done this, that guy is, so you don't do, no need to do all this all games. You just need to learn debug, learn how to work, then you can work. So that's how. So I think this class you might have learned like how to debug. If you don't know something, how to get some commands, get the commands, learn how to know, I think. And like encounter, this is how, this might be a simple, but if you ask some 6-7 years guys also, he don't know how to add a cell, how to add a net. If you ask me how to connect that port to net, I don't know. So that's how it will be. But most of the guys, you guys, I just want to explain you all the practical things. a 3 at least a 5-year guy should know. If you go and do this in the industry, you are almost equal to 6 years guys, 5 years guys. I'm sure you are saying. So just practice this. Just only we need to do practice. I think straightforward. I have gone to cell level, net level. How to edit the net names, how to create a net, how to create a cell, how to do it manually, how to do like movement a cell. Why we need to. Most of the guys in the industry don't know. They even don't click on that cell like in the move mode, because they'll be thinking, if I move the cell, I don't know what the tool will do internal logics. It will not do anything. If you do move a cell, if it is a routed design, that vias are not on the track, so the cell will be open. If it is a place design, nothing will happen. We just need to see overlap should not be there. That's it. So straightforward, straight away. I just want to make you to as an experienced guy. That's why I'm doing all the manual things like that straight in the tool. You move the cell, edit the cells, create the cells, nothing. Now I have done all these things. No, nothing will happen. You just no need to worry about the functionality. Functionality is already nothing in the leg. It will not do anything. If you add end caps, everything is done. And we need to add one set of tap cell, because there it is done. If we don't add the taps, we'll get LUP violations in. So what are PV will get error. So that's all. So I think so for next class now, you prepare some topic which is more interesting and like manual. It should be manual and the tool based, not like I cannot. I don't want to make it as a theoretical. So if I sit with you and I have worked for this much time now, like at least 1-2 points you might have remember, 1-2 commands you might have written. Okay, this is how we can get all the commands. This is how we can. So you got na. So is this class is helpful for you or? Yeah.
Actually, once we create this voltage island, we will create. Then the isolation and how we need to add on.
Actually, this voltage and I have explained now. This is for only IO ports.
Okay.
From IO port to one more IO port. So if it is for suppose this is normal cell which is in the core, and this is in different voltage. If signal is going from here to here, so I need to check this connectivity also. So I have connected now. So all the corresponding cell are connected. That's what I have to show even before. So connection is also done logically. Physically only routing. If you do route design, it will route. So the thing is like, if a signal is going from here to this, so this is the output point, this is the input port. So no need to do anything if it is on off. If this is on off, or else this is on off now and this is always on, then you need to do something, because it is from always on off to always on. It is getting power, so it is getting the input. That should not be X. Suppose this cell is off and this cell is always on, this domain. So then input will be X. So what we need to do is like here in this area, you can add one more clamp cell. So for that clamp cells also declared all the power nets, power domains, power voltages, and the power VDD pins is there. Encoder cannot edit that. Only that UPF, in that commands will be there UPF. Only that UPF can do that. So you need to source that UPF. You can execute manually also with that UPF command. So what it will do is like, it will change all the connections of that pins, VDD pins, and then you need to add a clamp cell here, and to that clamp cell enable signal we need now, that has to be given logically from top, whatever the multi-unit demand. So whenever the this block is off now, we should get an enable signal. So your question is, what we need to do? You just add a clamp here. That's it. You find the clamp cell or isolation cell, you add it, and you do connections. That's it. And forget about the enable signal, that has to be given from power team top level. So based on the logic, when it is going to off, so whenever this is going to off now, some signal will come at the end of the some end signal will come, then only it will go off. At that time we need to give that one more signal to enable signal. Suppose if it is on off, then definitely power getters will be there. Power getter will be placed in DC chain, all the power getters will have enable signal. So that enable signal will also give to the clamp cell. So whenever enable signal comes, power getter what it will do? It will switch off. This domain will be off. What that clamp cell will do? It will not take the input. It will give always 1 or always 0 based on cam 0 cam 1. So that's it. That's done. Are you happy? No, I just want you like think as an seriously. I'm saying there are 15 years guys, 20 years guys, 8 years guys, 9 years guys. They still like do the things manually. They still don't know like whether I can move the cell. Oh, this pin is there. What to do? Like you don't feel like that. Whenever we work now, we should work in a style like it should be in a manner like these are the steps I need to do. And these I can do. If not like this, I like this. If not inside buffer, add out buffer and out. Or else if those don't work, I'll create a cell, I'll create a net, I'll do manual corrections, I'll do logical corrections. So that's how you need to learn more about the tool. Yeah. Thanks, man. Bye. Yeah. Clustering in the cells like a group of cells have been placed in a near closely. So in the design, if many cells have been placed, that area is packed now, then we call it as clustering. So sometimes clustering we have to do, sometimes clustering we have to avoid.
For avoiding this, yes, pens, gates, and
No, not that. For clustering we need to put region fence guide. To avoid that, blockage we need to put, partial blockage.
cadence.
Cadence only, cadence also has partial blockage. Region guide and fence is like you can Google it. So that's like bonds will be there in RCC. Here it is like here also we call it as bonds, but region there it is heads off. Region what it will do is like what are the cells you have placed whenever you are creating a region, creating one. You have to specify these cells and you have to specify it is region or fence. If it is region guide or region fence or guide. If it is guide, that means suggest that tool is telling we are saying to the tool place these cells in this, try these cells to place in this. If not, you can move that cells upside like place other and other cells also in this region. Region means some other cells can come and sit here, but these cells has to be placed in this region only. Fence means the other cells should not come here, these cells should not go, and these cells only these cells has to be sit in this box. That's it.